Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh. Today we will learn about Boolean Algebra. Boolean Algebra for lecture 14. Okay, this is the last chapter that we in the mathematics discrete. Okay, for this chapter, there is this is the lecture content. Introduction to Boolean Algebra is presenting Boolean Function, Logic Gate. Okay, for this, for an introduction, the circuit in a computer and other electronic device have input, each of which is either 0 or 1. Okay, previously we learned this in the logic fundamental of logic in the beginning of this lecture, which is 0 is true, 0 is false, 1 is true. Okay, here okay, and produce output that are also 0 or 1. Circuit can be constructed using any basic element that has two different states, but the basic rule of logic can be used to design circuit. Okay, this rule form the basis for Boolean algebra. Okay, for Boolean algebra, provide the operation and the rule for working with the set 0, 1. Okay, true, false and true. The three operations in Boolean algebra that we will use most are complementation, Boolean sum, and Boolean product. What is complement? Complement is something different, which is 0 complement is 1, 1 complement is 0, which is previously we learned this also. 0 complement of true is false. Okay, so for Boolean sum, it is like an or in the fundamental of logic, which is true or true, it become true. Okay, or right. Okay, when 1 plus 0, it become 1 because of true or false. Okay, 0 plus 1 is become 1. Okay, for here, 0 plus 0 is equal to 0 because of false or false, become false. The Boolean product, here, the Boolean product, okay, for the Boolean product, okay, for the Boolean product denoted by n. Okay, 1 and 1 is 1 times 1 is equal to 1. Previously we learned true and true. When it is true, then become true. Others it become false. Same like this. 1 times 0 is become 0. 0 times 1 it becomes 0. And 0 times 0 it becomes 0. Okay. Unless parentheses are used. The rule for precedence for Boolean operator are: first, all components are computed; second, all Boolean product; then third is all Boolean sum. This is like the algebra manipulation, which is we have to consider yang dalam kurungan dulu kan. Lepas yang dalam kurungan kita selesaikan, kalau ada darab kita selesaikan darab dulu, lepas tu baru kita buat tambah. Okay, so this is the solution, which is we have 1 times 0, which is true and false, is become false. Then for this statement, which is false or true, 0 plus 1, it become 1. But here it's complement. So complement of 1 is 0. So 0 plus 0, false or false, become false. Okay, so 0 is the final answer. Okay. For translating Boolean algebra to propositional logic, equalities in Boolean algebra can be directly translated into equivalent of compound proposition. Conversely, equivalent of compound proposition can be translated into equalities in Boolean algebra. Rule of translating, like previously I told, which is 0 correspond to false and 1 correspond to true. Complement is operator complement here that we learned previously, and Boolean sum we replace it with plus, replace it with the V symbol here, and the Boolean product times we replace it with something, this symbol V terbalik ni kan. Okay, so how to translate from Boolean algebra to the uh, to to the form? Okay, translate the this statement, the equality found in example 1 into a logical equivalent. So we want to translate it into logical equivalent statement. Okay, so for this, 1 replaced with T, 0 replaced with false, and this is this is product, right? We replace it with V terbalik ni, and plus here with or symbol, and this is complement, right? Complement, right? Complement outside the bracket, then 0 is 0 is actually the 0 is false here, but it's okay because of here this statement, which is this statement is sum, which is or, so the value will be the same even though the symbol terbalik kat situ kan. Okay, so example 3, true, or we want to translate from logical equivalent to the Boolean algebra, which is here in a bracket, true and true, which is 1 times 1, and this is or is plus. Okay, and complement of f is complement of 0, and the answer is true, so the answer is 1. Okay, so Boolean variable and Boolean expression. Boolean variable, which is b, the variable, the element is 0 and 1. So then b1 is equal to x element of b, which is we know that x is the element either 0 or 1, is the set of possible singleton 0 and 1. The b square is equal to, okay, this is the pair 1. The pair is inside b. The element of b is 0 and 1, is the set of all possible ordered pair of 0 and 1. The variable x in b1 is called a Boolean variable, which is variable x1, x2 in b2. A Boolean expression is an expression made up Boolean variable, which is and Boolean operation. This is the Boolean expression, which is x, complement of x for b1, x plus y. This is a pair, and because of its pair here, so it's from b2. Okay, so x times y complement, and it's b2. Okay, this is the example of Boolean expression. Okay. Okay, for Boolean function can be represented using expression made up from variable and Boolean operation. In other words, each Boolean expression represents a Boolean function. It is denoted that by b and to b, the value of this function are obtained by substituting 0 and 1 for the variable in the expression. So for the example, for the Boolean function is the function f(x), x times 1 y complement from the set of order pair of Boolean variable to the set 0, 1, b power of 2 to b, which f11 is equal to 0, f10 is equal to 1, f01 is equal to 0, f00 is equal to 1. So if we want to represent this statement into the table, we know that x for this function, okay, we have to consider all the variable. Because of the variable is x, y, so the pair is 1, 1, 1, 0, 0, 1, 0, 0. So for the function x times y bar, y complement, which is we have to find y complement. So y complement is when it's 1, it becomes 0. When it's 0, it becomes 1. And when it is 1, it becomes 0. 0, it becomes 1. So for this, for these two, okay, for these two, okay, for these two, okay, x times y bar, okay, for x times y bar is, it is 1, 0 is become 0 because of true or 2 and false is become false. Okay, sorry, this is okay. 1 and 1, it become 1 because of an operation. 0 and 0, it become 0. 0, 0 and 1 become 0. So this is the final answer for the Boolean function. Okay, it's quite easy, right? The last chapter. Okay, for the Boolean function of degree n. Okay, previously b power of 1 is set all possible singletons, 0 and 1 has been introduced. This is called the Boolean function degree 1. Okay, for this is, okay, we know that the pair is x1, x2. So the highest number is x2. So this Boolean function degree 2. So for bn, if we have the pair and the highest is xn, we know that the degree will be degree n. Okay, this is the Boolean example of Boolean function of degree 1. So we know that the element is 0 and 1. Then from 0 and 1, we can produce f1, f2, f3, f4 pair here. For degree 1. Maksudnya possible pair. Okay, maksudnya dia kalau dia 1, 0 sama ada 1, 0, 0, 1, 1, 1, 0, 0. So, in other words, Boolean function of degree 1 produce 4 different Boolean expression. For this example, this is Boolean function degree 2. When it is degree 2, we have 2 elements here. Then we have how many pair? Okay, so the possible pair for this is 16. Degree 2. Okay. Actually, this is like previously we learned about logical equivalent, right? Okay, we know that when we have 1, 2, 3, 4, then we know that our maksudnya kita punya possible pasangan yang ada dalam tu ialah 2 power of 4. Okay, which is 16. Okay. For this is the, if the pair is 4, then it become 6, 5, 5, 3, 6. And when the degree is 3, it become 2, 5, 6, which is, when it is degree 3, it is 2 power of 3. Then we know that the pair, the pair for the Boolean function is 2 power of 3. So it become 2, 5, 6. Okay, same. If you want to calculate this, for the degree 4, it is 2 power of 4. Then 2 power of 4. Then we can get 65536. Okay. Okay. For example 5, find the Boolean function represented by x, y, z, x plus y plus z complement. Okay, for this we know that our variable is x, y, z. So that we have to define x, y, z first. Then we know that we have to find x times y. Then this is the inside the table x times y. Then z complement. Okay, this is same like truth table that we learned previously. The difference is when we put 1 it is true, when we put 0 it is false. So the how to solve this is the same. Okay, so now we know that x times y plus z complement will become or operation, which is 1 0 1 or 0 become 1 1 1 is become 1. Okay, 0 0 is become 0. So when it is 1, so it become 1. Okay, this is 0 because of 0 0, and this is another 0. So the rest is 1. Okay, so this is the final answer for the Boolean function for example 5. Okay, this is the Boolean identity. Okay, same like previous slide. There is this uh, commutative law, associative law, distributive law. Okay, for the representing Boolean function, sum of product expansion. Okay, first, given a Boolean function, so we have to solve the Boolean function first, then we have to find the one. Okay, this statement, you have to read it by yourself. Then look at the example. Okay, find Boolean expression that represent the function f x y z, which is given in the following table. Okay, x y z, then this is the, and for the f is the final answer. Okay, this is the final answer. So we want to find the Boolean expression that represent this. Okay, to represent f, the only expression that has the value 1 is, okay, here we consider the answer 1, which is 1 come from when x is 1, z is 1, and y is 0. Okay, look at the basis, okay, which is x1, y0, z1. Okay, for this particular answer, because it is 1. Okay, such expression can be formed by taking the Boolean product, which is, so here we produce here from the value x is 1, so x, y is 0, so y 0, because so we represent it as y complement. Then z is 1, so represent it as a z. This product is x times 1 complement times z as the value 1 if and only if x is equal to y bar is equal to z is equal to 1, which hold if and only if x z is 1 and y is 0. Therefore, the final answer for this Boolean expression is x times y bar times z, coming from this statement, and it is it's come from this. Okay, so this is the final answer. Okay. For the example 6, is illustrate a procedure for constructing Boolean expression. Each combination of value of variable for which the function has the value 1 lead to Boolean product of the variable or their complement. Okay, this is another example of sum of product. Okay, for this sum of product, okay, if we solve this function, we get, okay, we get the final Boolean as function is this. So now, in order to get the sum of product, we have to look at the function that give the value 1. Okay, for this one, we have to refer back to the fundamental, to the basis x, y, z, which is this one, refer back to this, and this one, refer back to this basis, and this one refer back to this basis. From these three bases, we can produce this Boolean sum of product, which is x times 1 bar times z, because of x1, y1, and x1, z1, and y is 0, so it's complement here, bar. Okay, so from this basis, we can create x bar y times z. For this basis, we can create x bar y bar times z. Okay, so for these three, we can conclude that sum of product for this expression is, okay, first is xyz here, xy bar z, then plus this expression and plus this expression. So this is the final answer for the sum of product expression for the function f(x,y,z). Okay, next is example 7b. Find the sum of product expression for this. Okay, so this is by using the using identity of Boolean algebra. Okay, so we want to find the final answer, but we have to use the law. Okay, this is we have to consider this table. Okay, this table in page 16. So please rearrange the equation to get the final answer. So in order to get this, we know that the final answer is in dalam persamaan yang dah dipecah-pecahkan macam ni kan. So from the beginning, we have to uh, find the law, associated law, then rearrange the equation to get the final answer. So this is the final answer. So this is like the fundamental logic yang hari tu yang kita buat kita buat proof tu kan. Okay, so for example for the logic gate. Okay, the logic gate ni selalu kalau dulu kita belajar fizik, kita nampak dekat dalam elektrik kan, punya chapter, which is kalau belajar fizik lah. Kalau tak, ini this is the new thing, tapi dia simple je. Okay, so Boolean algebra is used to model circuit of electronic devices. Each input and output such a device can be thought of as member of 0 and 1. This is input 0, 1, and output pun such as 0, 1 jugalah. Okay, a computer or electronic device is made up of number of circuit. Each circuit can be designed using the rule of Boolean algebra that was studied. The basic element of circuit are called gate. Okay. And each type of gate implement a Boolean operation. Okay, for this section, okay, read it by yourself here. And such circuit called combinatorial circuit or gating network. Okay, so we will construct in combinational circuit using three type of element. This is the what we call the inverter symbol for in the circuit. This is the inverter. When the input is x, then the output is complement of x. When the input is 1, apabila dia lalu je sini, dia akan jadi 0. Okay, this is inverter. Okay, another symbol is, okay, this is get or. Okay, meaning that every time you pass this, it become the plus operation, which is OR operation. So sum, Boolean sum, or we call it as Boolean sum output here. Okay, or this is OR get. Okay, so next is, this is AND get. Okay, this is AND get, which is every time ada unsur X dengan Y lalu, dia akan jadi darab lah kat situ, which is Boolean product. Okay, AND ni dia bentuk macam ni kan tadi, or dia bentuk yang macam ni kan, dia macam wow bulan tu. And ni. Okay, so Combinational circuit can be constructed using a combination of inverter OR gate and AND gates. When combination of circuit are formed, some gates may share input. Okay, for this is the example of combinational circuit, which we have X, Y. When it lalu dekat, this is gate apa tadi? Yang ni ialah gate AND gate, right? This is AND gate. Ni ialah AND gate. So, because of AND, it is product rule, which is X times Y. So, kat sini kita tahu this is complement tadi kan. Every time X lalu kat sini akan jadi X bar. Okey, lepas tu Y dengan X bar, bila dia lalu dekat this is AND gate, dia akan jadi product rule. X bar times Y. So, yang ni kita tahu ialah OR gate. So, our input is this and this. Okay, so because of dia lalu kat OR gate, jadi yang atas ni akan tambah yang bawah. Mudah je kan? So, dah boleh ambil fizik lah yang circuit-circuit ni. Okay, so example of combinational circuit. Another example, if we have three input here, then it lalu dekat OR gate here. Dan lalu dekat OR gate, so kita kena buat tambah lah setiap operation tu. So tambah, so dia akan jadi tambah, akan jadi sum rule, right? Okay, when it's lalu dekat kat sini inverter, kita kena tukar lah. From X akan jadi X bar, from Y akan jadi Y bar, dan from Z akan jadi Z bar. So kat sini pula dia lalu dekat N pula, dia punya gate N kan. So semua ni kena darab. So daripada sini kita dapat output dia yang ini. So kat sini, pada sini daripada this expression and this expression, dia lalu pula dekat AND gate. This is AND gate. So the final answer kita kena darab lah. Kalau kita ada dua expression macam ni, memang kita matematik kan, kita kena buat bracket. So kita dapat lah the final answer. Okay, so this is the thing that we had covered just now. Okay, so good luck for final exam. Actually, this is not this is previous kalau kita tak ada MCO hari itulah. Tapi sekarang kita dah ada MCO, so lagi minggu ni ialah minggu. So next week is last lecture, lepas tu ada study week. Lepas tu kita ada final exam. Final exam nanti saya bagi tahu jadual. Final exam kita pun secara macam assignment lah, saya bagi buat kat rumah, lepas tu jawab kena upload. Okay, tapi ada dalam duration masa yang tertentu lah. So good luck for your final exam, and this is your last lecture, and good luck. Study betul-betul, buat semua tutorial, dan boleh jawab juga soalan final yang lepas-lepas daripada boleh dapat dekat library punya page. Okay, terima kasih. Assalamualaikum.